Okay, good afternoon everybody. Welcome to the final session on day one of Ignite. So you're here today to hear us talk about Trustpower's journey to the hybrid cloud. My name's Steve Bunce, I'm the Software Development Manager at Trustpower. Joining me here is John Hopper, who's one of our senior devs. So we're going to look at initially who we are, our move to cloud, with a focus on Azure, why we did it and how we got there, and just some of the lessons we learned along the way. So just to start, so who is Trustpower? We've been around for over 100 years, starting life in Tauranga with a single power station back in 1915. So fast forward to 2016, and we now use cute dogs to advertise our bundled services. We offer power, gas, phone, and internet. We're not the biggest power company, but we're strong competitors in today's markets. Traditionally, we're a power generator and electricity retailer. We added gas back in 2013 to our portfolio. We've tinkered in telco for quite a few years before launching our fully fledged ISP. We're currently the fourth largest ISP in New Zealand, and we're the largest provider of fibre internet services in Tauranga. But we're also now reaching into other areas such as Auckland, Hamilton, Wellington, and Christchurch. So aside from the retail side of the business, we also generate electricity from our wind farms and hydro stations across both New Zealand and Australia. So Project Blue Sky. Yes, a blue sky has no clouds, but it was the kind of best we could do at the time for a project name. So what is it and why did we do it? So this is our head office in Durham Street, Tauranga. It's very flash, state of the art. It's won awards for its design. We moved in here in February of this year. Our previous home was overcrowded, it was cluttered, and didn't support us for future growth, or the way we wanted to work. So our journey to cloud was driven by a desire and need to move out of our current premises. We moved our applications and infrastructure between data centers in Auckland and Wellington, as well as Microsoft Azure. Our newer offices were not designed to host data centers or server rooms. So there is some hosted IT services, but not very much at all. We also needed to support activity-based working, which I'll come on to shortly. So why did we do it? So we wanted to implement technology that reduced technical and business risk. We wanted to invoke highly available and easily recoverable environments in the event of disaster. Also to provision dual redundant networks and failover capability. We looked at reducing capital investment. Pay-as-you-go model is seen as advantageous. We can dial up and down services as we need to, but obviously this can also be a risk for cost. So speed to market is also a driver, so rapidly provisioning of new products and services, and John will talk a bit more about that shortly. So the need for ongoing design work and procurement is reduced, and this releases my team to focus on areas of innovation and services and delivering solutions faster. So as part of our move to the head office, we took the opportunity to review how we work together as an organisation. We looked at how we work and how we wanted to make better use of a new modern environment and change our behaviours to ensure we work in a collaborative and fun and energising way. We have gone from having our own desk and being measured by the time we spend there to working in a range of work settings that we choose from, depending on the type of work we're completing at that time. We now work more collaboratively with others rather than completing tasks on our own. We are enabled and empowered by management to get tasks done in a more open and transparent way. We no longer need to be located next to files or resources of what we need to do our jobs. Through smart technology, we can access resources from anywhere. Azure has helped us to achieve this new way of working. So paper intelligence. Our new ways of working didn't support having dedicated areas for storage. We didn't want to move the clutter from one building to the next. So we engaged with paper chasers throughout all business units. And these guys went around looking at our high-use paper processes. They issued paper intelligence guidelines, promoted think before you print. We implemented follow me printing to avoid waste. We didn't ban paper, but we just made sure we were using it intelligently. We used technologies such as electronic signatures and advanced scanning to reduce our dependency on paper. A review of what we had led to huge amounts of documents being scanned and destroyed. And this shipping container, which was on our old premises in the car park, was just full of paper and documents. And this was all scanned to fit on a single USB drive. So to change the way we needed to work, we needed to use more technology and make better use of the technology and applications that we already had. Not everyone embraces change or new technology, and it can freak some people out. So we introduced tech taster sessions, where new and existing software was presented and demoed, giving users the chance for Q&A. So now we work in a much more relaxed and collaborative environment. We no longer have to battle with trying to find a room for impromptu meetings. There are multiple different settings appropriate for the type of meeting or discussion that we need to have. So these are the spaces that we typically work, kind of process and focus areas. So think of process as day-to-day tasks, conversations are happening while you're working, and working closely with colleagues. Focus is do not disturb, leave me alone, I'm trying to concentrate, phone's on silent. Kind of works in theory, but you still get a few interruptions. So just to recap, our move to the cloud was really one of the enablers for this new way of working and our move to our new office. So how did we get to the cloud? Well, the first thing we had to do was figure out what we had and how we worked and how they worked. Yes, we had documentation, but like most organizations, it wasn't particularly complete or searchable, and we didn't know where a lot of stuff was. We partnered with HP to review our applications and our environments. We discovered apps we didn't know existed. We discovered dependencies in those apps we didn't know existed. So things like linked databases, linked servers, buried amongst stored procedures. And quite often we didn't know they existed until we tried to move it and the application failed. So at the start, we had over 200 applications to review, and we had to decide what to do with legacy technologies such as classic ASP and .NET 1.1, and we still have a few of those hanging around. So then we had to look at the logistics. How do we move these applications into the new environment once we've decided where they need to go? We discovered there was lots we didn't know about our apps and environment, and more importantly, how our internal customers were using some of these apps. So following that assessment, we kind of mapped them all out, how they integrate, how they talk to other applications and databases, where the data was stored, and that kind of helped us decide where the appropriate place to locate them. We asked ourselves, do we need this app anymore? Is it still being used? Is there an alternative software as a service that can replace it? We looked at all sorts of logs to determine how the apps and databases were used. We pushed data into systems like Splunk to create dashboards, and we used an app called Blueprints, which was a really cool way to actually map out the applications and all its dependencies, including databases, web services, or absolutely everything. So Azure changes all the time with new features and products and services, but they're not always 100% complete and can remain in preview for quite some time. The app service environment was not even about when our project started. This came along a few months in and offered us a real alternative to how we host the apps and as an extension in our corporate network. We also looked at Azure Pack for an on-prem version of Azure, but it doesn't have the full capabilities that we needed, so it was discounted at that time. So web apps by default are public-facing, so we needed to look at securing them. We don't want all our internal applications exposed to the public. So data location and accessibility. Where should we host our data? If our application's in Azure, should the data sit there? Are there any security reasons why we couldn't or shouldn't host it there? Fears. There were lots of fears going through this project. Loss of ownership and control, fear of the unknown, fear of constant change to the cloud platform. Will it put me out of a job? And fear of the costs we could easily lose control of. We made a number of assumptions and set expectations within the business that transitions would be smooth. There would be 100% uptime during the move. It would be seamless. No one would even notice what we were doing. We quickly learned from that mistake. And costs. So how much is the total bill going to come to each month? How do we estimate the costs? We have over-provisioned services, and it can become incredibly costly if you don't have the right processes and reporting in place. So we had to think about all of these items to determine what we were doing was the right thing for our business. So reviewing our EA principles, so looking to see how Azure fitted in, along with our development standards and frameworks. These were constantly updated and reviewed throughout the life of the project. We needed to ensure we meet our corporate policies, such as data security, sovereignty, as well as application security. Logging and monitoring, we wanted to centralize these to be more proactive. We have many different approaches and tools. And this consolidation and standardization is ongoing. For our Azure-hosted apps, we assessed our use of App Dynamics at the time, and we moved towards New Relic because there was better and there was more support in the Azure platform. So local resources, what access to data on our file systems do we need to connect to? How do we access it in a secure way? Outages. What sort of outages can we live with? What ones can we not live with? What can we do when there is an outage? I guess that comes back to that loss of control. We no longer control that environment, so we're having to log support tickets with Microsoft. So almost all our services are set up to be highly available within Azure and across our data centers. So we host things in Sydney and Melbourne. And then lastly, DevOps, looking at changing our mindset about how we automate and script our deployments so they're repeatable and we can do them really quickly. So we ended up with these principles. We had to deliver fast for the project to meet very tight timeframes. We were not afraid to try something new to help achieve this. We didn't get our communication right until the final stages of the project, as I've mentioned. And it's really important that you keep everybody informed of what you're doing. Business users, take operations and the support teams along the journey. Otherwise, you'll find that your project team may be expected to support the new environments post project completion. So how did we eventually get the communications right? We held meetings with the business unit managers. We provided regular updates on our intranet. We sought approval from users to release the applications into the new environments. And we used all of these tools that you can see to communicate within the project, within technology, and to our business. So it is a hybrid cloud environment. So we still have our own infrastructure running in our data centers with a minimal footprint in the head office. So this slide shows that we took the opportunity to rebuild servers to the latest version of Windows Server. It wasn't possible in all cases, and some had to be lifted and shifted. You'll note there's very few that we moved into Azure here, and this is because we focused on platform as a service, not infrastructure as a service in Azure. And for these servers, these were for applications where PaaS was not an option. So one of the biggest things around the process of migration, the actual transformation process, and this was really well defined and it was tweaked as we went through. So at the start of this process, we started with around 150 applications and ended up with about 90. So we retired many of the apps from the environment. Either they weren't used, they could be consolidated, or they could be replaced with other applications. So we assessed where they were, where the databases were, how they were used, how they were integrated, and whether they could go to platform infrastructure or software as a service. We also asked ourselves, does the app need to be highly available? So the transformation and standardization of the applications. So what this meant from the .NET perspective was they were all upgraded to the same .NET framework version. We created NuGet packages to consolidate and upgrade code items for common functions and features such as error handling and logging and monitoring. So all release processes were scripted and repeatable. And at this point, the applications were smoke tested. We were not changing any functionality of these apps, so there wasn't a full regression testing. So there was some cases of applications, but the majority, it was just a quick smoke test just to make sure that they were all running as they should. And then once they were ready to be deployed, it was merely just a cutover, a change to a URL for the users. Links were updated on the intranet. We then monitored the logs for performance and errors, and we just made sure that we could respond quickly to any issues. The project team was quite separate from operations at this point, so it was really important to make sure that your service desk teams and operation teams are actually really involved in that process, because that you could find that an application wasn't working and we just weren't aware of it for could be hours. It was great walking into a meeting room just to get lynched when you weren't even aware there was an issue with an application. So I'll now hand over to John, and he's just going to talk to us around what Azure services we're using and how we're provisioning some of the apps and services.
Thank you, Steve. So as Steve said, I'm going to talk to you about what Azure is, what we're using Azure, and what we've done since we've actually done our migration as well. So you can see what's available in Azure. There's quite a lot. I call it my toy chest. There's something new to pick out every day, and also just something new to explore. But when it comes to actually solutions and things for the job, it becomes a toolbox, picking the appropriate tool out for the actual job itself. So there's a number of things in preview in Azure, but the thing is don't be afraid to try it. Don't be afraid to try something new, because it might be just what you're actually looking for itself. So what you see now is what we are now using. We concentrated around the web, the storage, and the networking initially. And since we migrated, we've actually expanded to use all the services. And as I said before, we are looking at what other would be better fit for what we need to do. So Steve has set us a challenge. Think outside the box. Just because we've done something that way before does not mean you need to do it the same way again. Is there a better way? Is there an Azure function or feature which actually suits the job better than you've done it previously? So I'm going to talk you through what we are physically using now. So we had a choice. So Steve mentioned before, public and private with your web apps. We had a choice. We could have gone with normal web apps and the app service and the app services. What you can see on the screen behind me is the traditional way they work. You get a single IP in, you get multiple IPs out, which if you're just interacting like a normal website, that's probably fine. But if you want to integrate with third parties, it's not so good because they want to lock it down to a single IP. If you were to scale to 2 instances of the app service plan, you'll get another 4 IPs. So therefore, how do you manage that? And also your web apps themselves. If you want to attach them to your corporate network, you have to attach every single application to it. You can't just attach the plan to it. But the good thing about it is you pay for what you use. If you're not going to use it and you scale it down, you only pay for what you scale it down to. So we're using an app service environment, which is, or containerizes in essence, the app services and attaches it to your physical network, and it's provisioned inside your VNet itself. So it's a simple way to simplify external communications and abstract away complexities around networking and also costs. Your app service environment is attached to your virtual network. Your web apps inherit that network by default. And also IPs. You get a single IP in across all your app service plans and all your web apps, and the same IP going back out as well. Therefore, you can actually integrate with your third parties or even other apps you actually secure down or lock down because you know where it's coming from. So you'll see the concept of a worker pool. An app service environment comes with 3 worker pools. So a worker pool is basically a way to set pricing tiers against what you want your services to use within that pool. So you can have a P1 and a P2 and a P3 tier system. So your more powerful apps go into P3 to help you try and juggle the costs. And the other thing you get with an app service environment is a front-end pool as well. Your front-end pool is where all your requests terminate. With a normal web app and a normal app service, Microsoft take care of that for you. In the app service environment, you've got control. So if you know you're going to have a huge influx of traffic, you can ramp it up and scale it up. If it's going to be a slow day, scale it back down and save some costs. The gotcha with them is you pay for what you provision, not what you use. You've got to have enough provisioned for you to be able to do your scaling internally. But that does come at the additional cost. So if you need 30 instances, at some point during the day, you need to scale up to that, and that's what you pay for, even if you use one of those instances out of the 30. So why do we choose the app service environment? There's dedicated compute resources and works in isolation. Because you are provisioning things ahead of time, you're isolated from everybody else. You know you've got the resource available to you when you need them. With it being deployed into your virtual network, you've got the virtual network support through inheritance for your applications, and also attaches to your express routes and connectivity back to your office, so secure communications. So how do we connect to Azure? So we're connected through an express route, which is a layer 3 connectivity using industry standard dynamic routing protocol, BGP. The networking people in here, know there's a couple in here, will actually know about that a lot better than I will. So through the express route, you can support speeds of 50 megabits per second all the way up to 10 gigabits. We've gone for the lower end because we're not doing high volume of video editing or anything else like that. So the good thing with the express routes, all your services in the Azure cloud can talk to you on-premise kit. So any of the databases or web services, you can do all the communications internally. You don't need to get them exposed outside. Interacting with virtual machines, you can do it all internally. They've just released the app service environment so you can use internal IPs only, so you don't even have to expose them anymore. We've secured ours a different way at the minute because app service environments weren't even about when we started the journey itself. They came along a few months afterwards. And also, with the express route, it allows you to connect to all the Microsoft Cloud services in all regions in that geographical region to actually improve your security aspects and security of your data. So Steve mentioned before, we've got about 2% of our VMs up in Azure. So as you can see from the diagram is, you can control everything. You can control it from the virtual machine, all the way down to NICs and IPs and load balancers, everything you probably would normally yourself, apart from it's not tin, it's software. So one use of these is our DMZ servers, where we've got our FTP server hosted. So we've got it available over multiple regions, both in Sydney and also Melbourne. But a common problem with FTP servers, if you've got multiple servers, is syncing of files. What Azure allows you to do is attach them to file storage associated with the blob storage, but your files, so you don't need to bother with syncing anymore. It's available on all 3. So that's IaaS attaching directly to your file storage. So since migration, we've not stopped there. We've been looking at the wider Azure functionality. We've been thinking about the issues we had during the migration. What were the problems? The application dependencies, third-party accesses to our APIs, making it more secure going forward and more robust, and also deciding, have we got the right tool for the right job? So one of the problems we had was we wanted to change the location of every single one of our APIs. We had to coordinate between internal applications. So if we wanted to migrate this API, these 10 applications had to be migrated at the same time or had to be changed at the same time. We had to coordinate with third parties, people sending us data. So we started to use API management. API management gives us the control of it basically controls the authentication, authorization, version management, and also transformations. What do I mean by transformations? If you're not ready or your customer's not ready to change from XML data or SOAP into JSON data, API management can cater that for you. If you want to allow people to navigate your APIs, API management allows you. And it also allows us to protect vendor applications from breaking changes through the version management. As you can see from the diagrams, we've got monitoring available to us. We can see the throughput of the APIs. We know what's being used. We know what's not being used anymore. Developers get a nice portal as well. So they can browse the APIs. They can try the APIs out as well. They request access to them if they haven't already got access. So since the migration, we've started using a lot more web APIs because API management is a RESTful service. So we've started to migrate our WCF services and also our legacy ASMX web services to web API, so we can actually put them through API management. And I was also talking to somebody earlier today, where they're actually starting to put Azure Functions and Logic Apps through API management as well, which is really interesting what's coming up on that. Another one of our problems was queues, our messaging system. We wanted to move it from one Azure subscription to another Azure subscription as part of our move. So we decided we need to have a centralized queue management system to remove the need for people to know how to implement service buses, and also direct access to the queues and sharing secrets. So what we did, our journey actually started with relays to get access to the APIs. That's got replaced by API management. With the queues, that was our initial mechanism for messaging. We've now gone on to topics, and we're exploring the event hubs as well now. But in order to abstract everybody away from that, we're actually using API management in front of it all. So we've written a web service, which we put behind API management to allow people to send us the data, and we will handle where we put it and how we want to deal with it. If we want to change the location, we can do from behind the scenes. If we don't think that person should be authorized, we can block access to those as well. So making ourselves a lot more secure. So another one of the problems was, as we went through our APIs, we found out there were quite a few of them which are complicated, overcomplicated. They were multi-purpose. Good thing is to keep your API simple. Let it do one job and let it do it well. We found some of our APIs weren't doing that. Logic Apps actually allows us to decouple components, which leads to greater flexibility in the way we work today. So yes, it is a workflowing tool, but it allows you to string your API calls from one to another, simplifying your APIs down themselves. Azure, or the Logic Apps, it comes with a number of different connectors. We've replaced our WCF listeners with Azure connectors for the service bus. So instead of us having to write that code, it's code out of the box. There's Facebook connectors, there's Twitter connectors, FTP connectors, you name it, it's probably there. Or if it's not there, it's probably coming tomorrow. And it allows us to push back into other systems, for example, Salesforce. So one good thing, we've had a real success story with Logic Apps, is we managed to remove a black box from the organisation. We had a system, it was not performing. Nobody quite knew what it was actually doing. It took over 6 months to implement in the first place, and we managed to rewrite it with Logic Apps within 3 weeks. So we got a effectively a crisis team together. What was this application doing? And we mapped it out from end to end. And so we actually replaced that system within 3 weeks. And since then, we've actually modified the system, which wouldn't have been that easy to do previously, to change with the adapting needs of the actual business. There were still issues on how we dealt with logic apps. How do we centralize what we're doing? So everlogging, and also more complicated decisions which need to be made. Because you're stringing your APIs together, you may need to deal with 2 or 3 different calls all at one go. And how you do that. We decided to use Azure Functions, and it basically helps us make our life easier. We can amalgamate different data sources. Azure Function is serverless code. It enhances the functionality of our logic apps to centralize our logic and to enable us to have reuse. Azure Functions can be used as webhooks, timers, service bus listeners, and it's really all done from the browser, and you can integrate it with your source control like GitHub, for example, as well. You can try it directly in your browser rather than directly in your browser, use them straight away. So during the migration, our primary aim was actually to get all our data into SQL Azure, to get as much as we could do into the platform as a service. However, as Steve mentioned before, it wasn't possible because of database dependencies, linked servers, and sometimes just the volume of the data with the tight time frames we actually had. So we've now got a mixture of on-premise SQL and also SQL Azure. If we want to deploy a new database, our preference is SQL Azure, and there's got to be a really good reason for it to come back to on-premise now from our perspective. And also, we're using different type of storage. So we're using blob storage, and we're using file storage as well. Our FTP servers are using the file storage. Our log files, our hard disk for the virtual machines are using the blob storage. So since the migration itself, we've been questioning, should everything be in SQL? Should everything be in relational databases? Is it the most appropriate thing? And the conclusion we're coming to at the minute is no. So what should we be looking at? We've started looking at DocumentDB, NoSQL databases. We're looking at table storage, again, using the right thing using the right tool for the right job. Log files coming in from multiple of our logic apps and our web apps, we're putting into DocumentDB. Basic settings for applications for rapid access, we're putting into table storage. So the other thing since migration is we've moved our public website itself. The way we deploy our web applications now is we deploy them into a slot. And then when the business is ready, we swap that slot into the production side. So when we were redoing the website, we said there's got to be a better way than taking the website down for 2 hours while we do an upgrade. And so we evaluated how we were doing things and why we were doing things. And with our old site now, we built once for QA, and we built again for production. So therefore, technically, we weren't deploying what we tested. Theoretically, yes, you were, but settings were changing. As I said before, deployments took anywhere between 1 to 2 hours, including the smoke test, which meant downtime. And what the downtime meant is we had to provision extra staff to actually come in to handle the additional call volumes as well. So we started down our DevOps approach. We're not full DevOps, we're trying to get there, but we've started it. We have automated quite a bit of our process. The arrows at the bottom just point to QA, because this is now our QA process. We provision completely new servers every time we want to build and deploy. every new test environment is completely rebuilt from scratch itself. And when we release into production, we use the exact same build as we used in QA. We don't rebuild anymore. So we know what's gone into QA and been tested is what's going into production itself. As I said, we completely re-provision the whole environment every single time. We run desired state configuration over it, we run our custom scripts, and we deploy the sites. And that actually allows us to have the new site and the old site up and running side by side for comparisons. And then with the use of traffic managers, we can transition people from the old to the new. This strategy is what we're actually going to be doing for patching of the servers as well. So therefore, the downtime will hopefully be eliminated. So, how are we doing it? We are using Azure Resource Manager templates and ARM deployments. So with PowerShell, so the templates and PowerShell, we can actually provision anything we want. We can provision infrastructure. So the virtual machines, we can do web apps, storage accounts, traffic managers, you name it. If it's in Azure, we can probably do it through automation. And it can be all executed from PowerShell. So what do the scripts look like? You can maintain them in Visual Studio or Notepad if you want to as well. You can see from your left-hand side a nice tree of what we're actually provisioning from the script. So you can see from the center, it is just pure JSON data itself. So it's nothing too scary, just the quantity of it and a couple of the syntaxes you need to know about. And on the other side of the screen, you can actually see the number of these templates we've got. We built the scripts to do a certain function. And we actually run all these for every single deploy as well. The good thing is, there's a lot of scripts, a lot of these templates available on GitHub today. So if you want to know how to provision highly available SQL servers, there's a script to do that. If you want to know how to build AD domain forests, there's a script, or there's all the tools to do that, all the way down to a basic web app or a virtual network itself. And it's really a good resource to actually use. So, running the scripts. We've actually created a PowerShell script to run the whole thing for us. So, we run a simple command. We say, deploy it please. Go from this environment to the new environment. And also, we actually tell it which one we want to go to as well. The reason we need to specify the old and the new is because we're taking a copy of our databases in the background. So the only thing required is a content freeze when we do this action. So, kicking off the build, deploys, it's using PowerShell. And as you can see, the first step, this is a QA build I was doing here. So the first step is actually runs or kicks off our build on our external build server. So we're actually using Appvia, we're not using VSTS. Because at the start of the project, we determined we'd actually use something different. So once that's been completed, we then start our provisioning phase. So we kick off a number of scripts for this, and we're actually re-provisioning every single bit of our environment apart from the database side of it. So once this bit's completed, you can actually see in the portal what we've done. So we've created 4 machines, 4 network cards, storage locations, and these are all hooked up to our traffic managers, which is another resource group, which are also static. And then once this is all provisioned, we then kick it off into our provisioning stages. We use desired state configuration to make sure our Windows components and Windows features are there. Our third-party installs are there for us. Our window updates have been run, so it's fully patched, and also that our monitoring agents are actually there properly installed. And then we actually configure the server. We wipe down IAS, we take away all the default configuration, and we make sure it's security hardened as well. and then we deploy our site and make sure that's security hardened in accordance with our CMS vendors' recommendations. And then once we've done that, we actually have a fully functional site. So this site here will be the new site, and the testers can go on there and do whatever they need to do to make sure they can get the green light. Business owners can go on there, they can make additional content changes on there, knowing when they want to go live, that's exactly what they're going to get. And the good thing is the old site is still up and live. So what we've actually got is 2 levels of traffic managers. We've got a priority level at the top, and then we've got a weighted one down below. We're using a priority one, so if we do need to take the site down at any time for whatever reason, we can just fall over to our unplugged sites. And then the actual traffic manager, the weighted traffic manager, has all the nodes we want on the sites. So we can either just swap it over, or we can actually add to it. We can slowly increase the traffic to that site itself. And when we're finally happy, all we need to do is turn the old off and turn the new one on. So I'm just going to talk to you a little bit about what we've learnt. We are on a constant journey. We haven't stopped. We are evolving in what we do and the way we're working every day. We're readjusting our thinking. And we're actually going to share a few lessons that we've actually learned along the way. So, as with all things, there are disadvantages. It's not everything. Yep. So, first of all is loss of control. We don't own the infrastructure. We don't control it. If there's issues, we need to rely upon third parties. We're moving our business critical functionality up there. So if something goes wrong, we need to get action fast. So the support team at Microsoft are great. Log in the support ticket, we get a really good response and turnaround from them. And also, it's a steep learning curve. For the people who are not on the journey, the people who haven't started at the beginning, it's difficult. Saying, you've now got all these new toys, and this is your new things you need to support. It is a steep learning curve for them, especially people who need to maintain it. So, there are more advantages, of course, than there are disadvantages. We're able to improve our DevOps approach. We can introduce more automation. We can increase the control and monitoring of our APIs and our integration layers. We're able to swap components in the background without affecting people in the foreground. The one thing we wanted to do right at the start of the process. We've got far less servers to patch now. All the web applications, they're up in PaaS. We don't need to patch those servers anymore. Microsoft take care of it for us. And they're constantly improving functionality with Azure itself. There's a lot going on. New features get released every day. And if it wasn't there yesterday, it might be there tomorrow, the feature that you want. The forums that they respond to the forum posts. And Twitter as well. And we've actually improved our communications around the business. So as Steve said before, our communications to the business was poor at the start. We've learnt, we've grown. We know what we need to do now in order to get something past the line and actually accepted within the business. Yeah. So how are we keeping people up to date? We actually run different sessions throughout the week for our staff or for the app support teams that we've got and other people who are interested to help them keep up to date. We do show and tell Thursdays, saying to the guys, this is what we're doing, this is how we're doing it, and this is where we want to move towards. We have Azure Fridays, and we've classified one of our spaces, the think tank. So we actually, the senior devs with Steve, we actually go away and say, okay, what is new? What wasn't there yesterday? Should we be using something else? Re-evaluating ourselves to make sure we're on the correct path. So as I said before, we've been given a toy chest and the mandate to actually use that toy chest as well, to choose the appropriate tool for the appropriate job. And this is why I feel it's enabled us to adopt the activity-based working approach with the technology. Steve, to you.
Thank you. So just to recap on a few things that we've talked about as we start to close out the presentation. So, you know, it does have a huge impact to the business. So explain what you're doing, why you're doing it, and when it's going to impact them. Don't fall into the same trap that we did at the start of the project and just think that it's not going to affect them in any way. From the technology side, I think we totally underestimated the effort that it would take to shift, you know, pretty much every single piece of IT equipment. You know, we were moving offices, so physical hardware, as well as all our applications moving. You know, it was a pretty huge task. Once kind of we got into it, you know, we had a 4-month timeline to get stuff done, and that was just totally unrealistic, which we soon discovered. But it probably took us double that, but it was still a huge achievement for, you know, touching every single piece of equipment in kind of, you know, 8-9 months. The learning curve was greater than we kind of anticipated as well. You know, with Azure changing and new features coming along, you are constantly reevaluating what you're doing and how you're doing it. And that kind of can, in some ways it can slow you down a bit, but in some ways you kind of know you're doing the right thing and you're moving to a really good place. So automation is really the key around migration. You know, automating those deployments so you can repeat it and repeat it really quickly. And John's kind of, I've talked a bit about the rate of change. So why did we do it? So just to recap, you know, we moved offices, we had to get out, we had to move all our servers and infrastructure. Potentially we didn't have to move our applications, but we took it as a really good opportunity to move it into Azure to get the most out of the cloud platforms, to help us with speeding up delivery of our solutions using the latest cloud services. We changed the way we work to activity-based working. We work in a much more relaxed and kind of open environment, and really appropriate for the tasks we're doing. We can just be sitting in a focus area concentrating on something, and then you realize you need to get together as a team, and we can just quickly move off to a space that's just allows us to collaborate and work on a problem together. So we've looked at, so we've adopted a cloud-first approach. We've looked at what services are in Azure before we start to write new code or design solutions, and we try to automate as much as possible. So that's pretty much us. There are some other sessions around this over the course of the week. So tomorrow there's a session by the New Zealand Fire Service, again, Journey to the Cloud. There's also a session around app services and service fabric that's kind of relates to what we've done. And then on Friday, securing and encrypting workloads in Azure. So thank you all very much for your time and for coming to see us.